Salam and welcome everyone. So today we're going to be working on the question on the screen that says the addition of 100 grams of a compound to 750 grams of CCl4 tetrachloromethane lowered the freezing point of the solvent by 10.5 Kelvin. Calculate the molar mass of the compound. Before we go on to solve this question, this is a question from the Atkins Physical Chemistry 11th edition textbook. This is from chapter 5, and this is from chapter 5b in particular, and we're dealing with freezing point being lowered in this particular question. So I'm going to reread the question and write out the important parameters as well as highlight the keywords. So the addition of 100 grams of a compound to 750 grams of CCl4 lowered the freezing point of the solvent by 10.5 Kelvin. Calculate the molar mass of the compound. The addition of 100 grams of a compound, so the mass of the compound, which is unknown, is 100 grams. We could also write M sub X, where X is just the compound or the unknown compound. I don't want to have to write compound all the way through. So M sub X is 100 grams or M sub comp is 100 grams. Was added to 750 grams of CCl4, lowering the freezing point of the solvent by 10.5 Kelvin. Now, the mass of the solvent, CCl4, is simply 750 grams. And CCl4 is the solvent because the solvent is usually greater in quantity than the solute. Hence, in this case, CCl4 is the solvent, so CCl4. So we're told that the freezing point lowered by 10.5. So changing T sub F is simply 10.5 Kelvin, right? Now, from this question, you already know what you're dealing with is the freezing point depression equation. We need that equation to solve this question. So we need to use the freezing point depression equation to solve this question. And that formula is simply changing T sub F, okay, is equal to K sub F multiplied by B, where B is the molality, K sub F is the freezing point constant for the solvent, as well as changing T sub F is the freezing point depression value. Now, I want to quickly mention something. With all this information, we're not even told to solve for anything. We're not told to solve for anything in particular, except for the fact that we're told to solve for the molar mass of the compound. So really, all this is just us realizing that we need to find the molar mass of the compound or the molar mass of X. Okay, so that is what we're supposed to solve for. So looking at this question again, looking at this freezing point depression equation, I have explained to you that this T sub F, changing T sub F, is simply the freezing. Okay, I'm just going to write it down. Freezing point depression value. So a change in temperature whenever the freezing point is lowered. We're told whatever that was to be 10.5 Kelvin. Then we have K sub F, which is just the freezing point constant for the solvent. And then B is the molality of the solute. That is the molality of the solute. Now, the freezing point depression value has been given to us. The molality of the solute has not been given to us. But another value that wasn't given to us, but we can easily find is the freezing point constant for the solvent. They do not necessarily have to give you in a question for you to know that constant value are constant. So you can always know the value, just like we know the speed of light value to be constant, right? We do not need, or the Avogadro's value or Avogadro's constant to be a constant value. We don't need to be given. We can always we can always find out what the freezing point constant for the solvent is by, of course, checking Google, or in this particular case, we have it in the resource section at the back of the Atkins Physical Chemistry 11th edition textbook. We have that value. And looking at the back of my page, I see that the value K sub F, okay, for this particular question, so let me write it down. K sub F, which is just the freezing point constant for CCl4, tetrachloromethane, CCl4 is simply 30 Kelvin kilogram per mole. So that is basically what this is. That is it. So we have the value for changing T sub F is equals to K sub F, and then all we don't have the value for is molality. But the thing is, we can input and substitute the value for change in T sub F and K sub F to determine the molality. But this question is actually asking us for the molar mass of the unknown compound. So, yeah, our work is not done. So now we're going to have to use our knowledge of chemistry and algebra to be able to go on to solve this question. Before I go forward, I have to explain to you that B molality is simply the moles, okay, of solutes divided by the mass of solvent in kilograms. So this is back to general chemistry. Moles of solute divided by mass of solvent in kilograms. So usually the units for molality is just mole per kilogram. So that's very important for you to note. So we're not just going to find value for B, we're asked to find the molar mass of the solute of the compound. In this case here, the moles of solute, the solute in question is the unknown compound, the solvent is CCl4. Now, you may be wondering, okay, yeah, we already know this. Let us just continue. Well, we are continuing. I have to now explain to you one more thing so that everything just comes together beautifully. Moles of solute divided by mass of solvent in kilograms. Remember, what we're actually asked to solve is the molar mass of the solute. So molar mass of comp or molar mass of X, that's what we're told to solve. But we know that moles, okay, number of moles is equal to mass over molar mass. So in this case, right, the N sub X, which is the number of moles of the solute, which is compound X, so N sub comp or N sub X, is equal to the mass of the compound or the mass of the unknown X. I want to use X again, like I said, because I don't want to be writing out comp all the time. I've explained that from the beginning, divided by the molar mass of compound X. So sorry, of X. So sub X. So this one, we can simply substitute. So rewriting the formula, we have change in T sub F is equal to K sub F B. We can rewrite that to simply be, remember the molality is going to be N sub X divided by molar mass of CCl, sorry, divided by mass of CCl4, mass of CCl4. So we're just going to substitute that to be changing T sub F is equal to K sub F multiplied by the number of moles of solute divided by the molar mass. So that would be N sub X divided by M sub CCl4. Now remember, N sub X is M sub X divided by MM sub X. So we're going to put this again here. So changing T sub F is just simply K sub F multiplied by N here. Number of moles here is just M sub X divided by MM sub X divided by M. Okay, so the mass of tetrachloromethane. So this is really the formula. For those of you who do not understand what I did, have patience with yourself. You can pause and rewatch it or just let the whole video run and then rewatch the video. This is just algebra. And I felt like I could determine the molality first and then remind you guys what the molality is and all that. But this is an advanced physical chemistry class. If you choose to determine the molality first and then from the molality, you break it down to finding the number of moles and then you break it down again to find the molar mass, that is fine too. I'm just trying to show you how all of these formulas connect. So basically all this information that I just solved here is the same thing as B. Molality is what encompasses all of this, which is just the mass of the unknown solute or unknown compound X divided by its molar mass, all of that information divided by the mass of the solvent in kilograms. So yeah, that is basically all that I explained here. So rewriting the formula in terms of molar mass, we calculate changing T sub F is equal to KF M, okay, M sub X, M sub X divided by divided by M CCl4. So let's cross multiply. So that will be changing T sub F multiplied by M CCl4 is equal to K sub F m sub x divided by m sub x. So that is that. Do another cross multiplication again. Remember, we're trying to solve for the molar mass of x, which is just this right here. So we end up with m sub x changing t sub f MCCl4 divided by KF M sub X. So this is what we have, and we're trying to solve for MM sub X. So MM sub X, right, is now going to equal, divide both sides by, um, you're going to divide both sides by changing T sub F MCCl4. When you do that, you end up with the MM sub X to be K sub F, which is the freezing point constant for CCl4, the solvent, multiplied by the mass of the unknown divided by the freezing point depression value, okay, that was given, multiplied by the mass of CCl4. So yeah, that's it. Now, when we go back to our question, we see that we have all the values that we need now to solve for the molar mass of the unknown compound. We have K sub F. I already explained that. We found it in the Atkins Physical Chemistry 11th edition. We know that's right here to be 30 kg per mole. Okay. We have the mass of X given to us from the very beginning to be 100 grams. Okay. The question also involves us, this equation also involves us using changing T sub F, which is just the 50 freezing point depression value. We know that to be 10.5 Kelvin. Then we're also given the mass of CCl4, which has to be in kilograms. And we have that to be CCl4 in kilograms. We have that to be 750, but we change it to kilograms to get 0.750 kilograms. You can see we have everything we need, right? This is just understanding of algebra as well as knowing the formula to use. So hopefully this is very helpful to all of you. So the molar mass of the unknown is just K sub F. We've seen that value to be 30 Kelvin kilogram per mole. So 30 Kelvin kilogram per mole multiplied by the molar mass, multiplied by the mass of the compound we're given, mass M sub X, that's 100 grams. And I'm going to convert it to kilograms. So I'm just going to say 100, okay, times 10 raised to the power of negative 3 kilograms. So basically, I'm going to change all of the grams to kilograms. And just that means I'm just dividing by 1,000 or multiplying by 10 times 10 raised to the power of negative 3. So we're going from grams to kilograms. So we're dividing by 1,000. I'm not gonna like write it step by step. So, but yeah, that's what I did there. So divided by changing T sub F. Changing T sub F is just simply 10.5 Kelvin. So 10.5 Kelvin. Okay. Multiply by M sub CCl sub 4. So that is the mass of tetrachloromethane in kilograms. So 750 grams would just be 750 divided by 1,000. So that would just be 750 from grams to kilograms. So 750 divided by 1,000 or multiplied by 10 raised to the power of negative 3 kilograms. So yeah, we have all that we need here to solve this question. So let's cancel out the kilograms, cancel out the kilograms, cancel out the 10 raised to the power of negative 3, 10 raised to the power of negative 3, cancel out this, cancel out the Kelvin here, and cancel out the Kelvin here. So what we end up with, the molar mass of sub X would just simply be 30 times 10, okay, 30 times 10 divided by 10.5 times 75, okay, kilogram per mole. So that is basically how you solve this question. So yeah, that's basically how it's done. When you input this information in the calculator, you end up getting M sub X is simply 0.380952 kilogram per mole. So this is the value in kilogram per mole. We know usually molar mass tend to be in gram per mole. So we just multiply this value by 1,000. Okay, 1,000. Put grams here. We put 1 kilogram down here. We cancel out. This is just converting from kilogram to grams. So M sub X It's just simply going to be 380.95 to 381 gram per mole. But then again, we're chemists, we're scientists, we have to put our work in the proper number of significant figures. If any of you have been watching me for a long time, then you know I do this a lot. I do it all my physical chemistry work, all my calculations, especially the ones relating to just chemistry, physics. Please put your work in proper number of significant figures. So we have 380.95 to 381 gram per mole. We go back to our question to find out the proper number of sig figs, which is just the lowest number of sig figs given to us. In this case here, we have 100 grams, so that's 3 sig figs. 750 grams is also 3 sig figs. 10.5 is also 3 sig figs. So our final answer has to be 3 sig figs. So if we put that down, we just end up with molar mass. So mmx is just simply approximately 381 gram per mole. So this is basically the answer to this question, 381 gram per mole. So 381 gram per mole. And that's basically the answer to this question. If you have any questions, suggestions, concerns, please make sure you put in the comment section of this video. I'm here to help you. I also wanted to mention that I'm going to be doing another of this kind of question in a different video. So make sure you watch it. I am definitely your go-to person for physical chemistry. So if you do have any question or you want personal tutoring, you can email me. And if you're a student who's struggling with any of your STEM related courses, whether you're in middle school, high school, or college, email me at shohabitutoring@gmail.com. I help students succeed in all their STEM related courses in middle school, high school, and college by my way of tutoring and mentorship services. So if you would like to be the best version of yourself in academia, email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.